Now let's see question 17. We want to graph log functions. Now we're in the function world. So whenever we talk about functions, we like to talk about the domain, the range, and their graphs, right? So domain for log, the value has to be greater than 0, which is it cannot be 0, cannot be negative. Okay, has to be a positive number. So same thing for this, x has to be greater than 0. Then for this one, means x minus 2 has to be greater than 0, which means we add 2 on both sides, which means x has to be greater than 2. And the value here is x plus 3. That means this one has to be greater than 0. When we subtract 3 on both sides, that means x greater than negative 3. All right, this is talking about domain of those 4 functions. Range is everything, all real numbers. So we write it as range from negative infinity up to positive infinity. Basically all real numbers. All right, now let's talk about graph of this. So remember, let me first graph exponential functions. Exponential functions and log functions are inverse with each other. So exponential functions, if we remember in my previous video, is either exponential decay, or let me use blue color, or exponential growth. Okay. The blue color is exponential growth. The red color is exponential decay. And the log functions are inverse with this. So inverse functions have a feature. They're symmetric with y equals the x line. So let's see this line, the green color is y equals to x. Inverse functions are symmetric with this y equals to x. So y equals x is a line of symmetry for the inverse functions. If the base, okay, here 3, is a base in log and also base in exponential, right? If the base is greater than 1, and we know it's exponential growth. So then, let me use this color. The log function would be this, symmetric to, to the blue color. Okay, so this would be the log function. So this, what kind of color? Purple color. This purple color is the log function. Log function, base 3, base 4, base 2, base 3, for all the base greater than 1. And usually when we talk about log, we want the base to be greater than 1. So that is to say, let me just re-graph, just graph 1. Because usually our base in log is greater than 1. So our graph of log, I'm going to use red color to graph. I have this point, and it goes like this, right? And this keeps going. It keeps going down to be any negative y value, keeps going up to be any positive y value. So that's a range. That's a range. That's why range goes from negative infinity up to positive infinity. And the domain, we see the x value. The x value will never be on y-axis or never cross y-axis to go to the negative side. So that's why the domain of log function is positive greater than 0, all right? So this is a graph of log base a of x, right? And the a is greater than 1. And then normally our log base is greater than 1. Okay, what is the difference when the base is different? So here I have 3, here I have 4. Think about when the value equals to the base, we get 1. So, or if x is 1, we get 0. So this point is a common point. The common point, because this is 1, 0 point. When the x value is 1, the function value becomes 0. And the difference is we can make this. If x equals 3 for a, right, let's see, this is 1, 2, 3. When the base is 3, we get 1. Let's see, this is 1 on y. So have this point on log base 3. How do we draw log base 4? Let me use green color. I would need x value to be 4 to get to 1. Right? And the graph is similar. I have this piece. And also I have this keeps going down to negative infinity. As you can imagine, if the base is 2, I would reach 1, right? When x equals 2. When the base, this is a 3 again. Okay, so that's for 3 and 4. Now, what about the values x minus 2? Remember we talked about transformational functions? So this is a horizontal shifting. So this is pushing log 2 of x 2 units to the right. So that becomes, so the 1, 0 point, this common point will be here. Let me use another color. Let me use this purple color. So this is for C. So this is for C. And because the base is 2, so if I start from here, I go 2 further, that's to 4, I reach 1. So my graph of C would be something like this, across this point, right? So this is a 2. Oh, hold on 1 second. Right, cannot be 2, has to be 3. You see, if x equals 2, I get 0. I get 0 in the value. No, that's not in the domain, so it's a 3, right? Because x is being pushed 2 units, because this is 1, push the 2 units to the right, that has to be 3. So this is common. Let me see, clear my draw. Oh, okay, that clears everything. Let me start from the beginning. So this is my x-axis, y-axis, right? So I want to draw this graph. This is 1. This is 2. This is a 3. Let me use blue color to draw the graph. So when x value is 3, 3 minus 2, that's 1. Log of any base value is 1, that's 0. So I have this point. And then when x equals 4, 5, let's do x equals to, no, 4. Let's do x equals to 4. 4 minus 2, that's 2. Then it's the same as the base. Then I get 1. So let's see, this is a 4. And then let's see, this is a 1 for y value. So I have this point, and I have this point, and I know log, so I can move. I know that's a horizontal shifting 2 units. Something called asymptote, right? Asymptote means a prohibited line, means your graph will never cross a line. So my graph keeps going down along this x equal to 2 lines, your vertical line, but it will never touch this vertical line. And then my graph goes to the up through this 4, 1. So I have important points. I have this 4, 1 point. I have 3, 0. I have this 3, 0 point. And the shape is a log. The shape of the graph of log is forever like this. Okay, unless you reflect, and unless the reflection is applied or rotation is applied. So this is a graph for C. Let's see graph for a D. So let me use green color to graph that. So we could have comparison. Now I see horizontal shifting 3 units to the left because I have x plus 3. So the common point of 1, 0 being pushed 3 units to the left. So that means here, right? So if x value equals -2, -2 plus 3, that's 1. Log of base 3, 1 equals 0. So I have this point on the graph. Then if x equals 0, what happens? 0 plus 3, that's 3. The value and the base are the same. So we get a y value equals to 1. So I have this point. Then I'm going to graph -3x equals -3. Because that's going to be my vertical asymptotes, which means my graph will never cross x equals -3 line. So this is a vertical line, has a name. It's called x equals -3. Then my graph goes through these 2 points, keeps going, and keeps going down along x equals -3, but it will never touch x equals -3. So the green color is my graph for D. Now let's say 18, we want to find distance between 2 points. Let's draw a picture first, then we calculate. Let's see, I have a point here, and I have another point here. So I want to find the distance from this point to this point. So what do? I can form a triangle. I can form a right triangle, right? Then I see the distance of those 2 points, just the hypotenuse of this triangle. So I can find the distance of the base. Let's call it B, maybe. If I find the distance of B, I find the distance of A, right, from this point to this point. Then I square them. I add them up, that's square root, right? So this is the square root of A squared plus B squared. Pythagorean theorem. Use Pythagorean theorem. So now, how do I figure out A and B? A is the difference x value and B, right? If I call this point has x value to be x1, this is second point. X value is x2. So I see the distance in the base is x2 minus x1. Same thing, how do I find A? If I call this point has y1, so the first point has x1 and y1, and the second point x2, y2. So A is the difference between the y values. So B is the difference between the x value. A is the difference between the y value. So now let's see this one. I call this first point x1, y1. I call this second point x2, y2. Then I just do square root. I use Pythagorean theorem. I square root of x2 minus x1 squared. That's my B squared plus y2 minus y1 squared. That's my A squared, right? Then I square root, right? Now let's plug in our values. So let's plug in our values. So our x2 is 2, x1 is 3. Then square this plus y2 is 2, y1 is 4, 2 minus 4 squared. Okay. 2 minus, okay, let's do step by step. Now I square root. Now I square root. 2 minus 3, that's -1. So -1 squared. Well, 2 minus 4, -2 squared. Then I square root. What's -1 squared? -1 times -1, that's 1. -2 times -2, that's 4. So 1 plus 4, that's 5. So get the square root of 5 to be the distance of those 2 points. All right, let's review, see what we have done. So to find any 2 points, the distance between any 2 points, we form this triangle. We want to use Pythagorean theorem. The base is the difference in the x value. The height is the difference in the y value. So we apply Pythagorean theorem because the distance just the hypotenuse of the triangle. So we get square root of x2 minus x1 squared plus y2 minus y1 squared, then square root. So we did it for A, right? That's a square root of 5. So the distance between those 2 points is the square root of 5. So similarly, let's do for B. We have -9. It doesn't really matter which point you call first one, which point you call second one, but you have to be consistent. If you call -2, comma 3 to be x, if you call -2 to be x1, then y1 has to be 3, okay? So -9 minus 3 squared plus 3 minus -2 squared. When we subtract negative numbers, we have to be very careful because subtract negative become positive. Then we square root. Then this becomes -9 minus 3, that's -12 squared, plus 3 minus -2, that becomes 3 plus 2, which is a 5 squared. Yeah, then we square root. -12 times -12, that's 144. 5 squared, 5 times 5, that's 25. So we get a 169 square root. So we have the square root. And then 169 is 13 squared. So square root of 169 is 13. All right, so the distance between those 2 points is 13. Now let's calculate for D. Use -2 minus -5 squared plus, plus 2 minus 0 squared, which is -2 minus -5 becomes -2 plus 5, which is a 3 squared. Then plus 2 squared. 3 squared plus 2 squared. 3 squared is 9. 2 squared is 4. Adds up. That's 13. So let me add square root signs. So everything is under square root. So in the end, the distance of those 2 points is the square root of 13. Now let's see D. We'll do the same calculation. 5 minus 2 squared plus 1 minus -3 squared. Simplify, that's a 3 squared plus 4 squared. Because the 1 minus -3 becomes the 1 plus 3. 4 squared. So this is a famous Pythagorean triplets. So 3 squared is 9. 4 squared is 16. 9 plus 16, 25. Okay, 25 square root is just 5. Okay, let me add square root signs for everyone. So I have a square root, 5 squared plus this, square root. Sometimes I just make one radical sign to be lazy, but better to separate them to make different ones. All right, square root of 25 is 5. So 3, 4, 5 is very famous Pythagorean triplets. That means those three numbers form a right triangle. All right. That's this. Now let's see 19. Okay, I'm gonna take a little bit of rest and do 19, 21 in another video.